Hello, Bacho. Good morning. Carry on from the last exercise we did from question 1 to 6 of NCERT. So, these questions are very important for all students of class 12th, like ISC and CBSE, all state boards, because all have the same syllabus. So, let us start question number 1.6 of NCERT book. There are four charges placed at the vertex of square ABCD. So 2 microcoulomb at the point of A and minus 5 microcoulomb at the vertex B, and at the vertex C is 2 microcoulomb, and at the point of D minus 5 microcoulomb, and the side of this square is 10 centimeters. So we have to find out the point of intersection of the diagonals. A charge of 1 microcoulomb is placed at the center. So at the center 1 microcoulomb, this is 1 microcoulomb charge placed at the center. O is the center, which is the point of intersection of these diagonals. So we have to find out the net force on this one. So this is a positive charge and this is also positive charge. Positive will repels from the Coulomb's formula theorems. This 2 microcoulombs repels 1 microcoulombs along this one. So we represent this by this force. So this is a force due to FC. For FC, the charges placed at the point of FC. And similarly, this is 2 microcoulomb, 1 micro, both are positive. This will repels 1 microcoulombs along AC. So therefore this force will be along this one. So we represent this force FA. So here FA both are equal in magnitudes and opposite direction. Therefore FA here, vector FA is equal to in magnitude FC, but its direction is opposite, so we represent minus FC. This is minus FC. Now similarly this is a minus 5 microcoulomb, this is positive, and this will they are opposite sign. Therefore minus 5 microcoulomb will attract along these ones. So this is the direction of attractions. We represent it due to the charge placed at the point of A. Therefore we represent it vector FB. Similar, this is minus charges, this is positive charges. This minus charge will attract along these ones. So it is a force due to the charge placed at the point of D. That's why FD. So these FD and FB is again equal. So FD and FB both are equal. Now therefore force due to FB is equal to minus FD. So they all are equal and opposite. So it means that it will cancel this and this force will cancel this. So that force on the charge, which is 1 microcoulomb, will be 0. So now total forces will be in that case FA plus vector FB plus vector FC and plus vector FD. So since FA equivalent opposite of FA plus FC, from here FA plus FC, take FA plus FC is 0. So FA plus FC is equal to 0. Similarly FB plus FD will be 0. Now FA will cancel out FC, FB cancel out this one, so final value will be 0. So net force on the charge which is placed at the point of O will be 0. Now question number 1.7 means question number 7 of chapter 1. Two charges placed 3 microcoulomb at A and minus 3 microcoulomb at B. What will be the electric field at the point of O? Uh, what is the electric field at the midpoint of O? Is the midpoint of this one, and distance between A B 20 centimeter. So we know that net electric fields definitely will be zero. This is positive charge. It's a direction of the electric fields away from them. Away. This is positive, away from this one along AB. So now it will be electric field due to charge QA will be along this ones. Now it's a value in magnitude. EA is equal to 1 upon 457 naught, and this is the formula, and QA divided by R square. So 1 upon 457 naught has the value 9 into 10 to the power 9 in SI system, and charge QA 3 micro. Micro means 1 micro. Micro means 10 raised to the power minus 6 coulomb. So it will be 3 times of 10 to the power minus 6 coulomb divided by your distance. Distance is 20 centimeter. Convert it a meter, divide by 100. 20 upon 100. This will be 20 upon 100. 20 upon 100 meter. Now this will be 0.2 whole square. Now this is the magnitude, and direction will be along AB. Now it will be the direction along AB. Now in second case, along AB. Uh, Now next, this is minus 3 microcoulombs. Minus 3 microcoulombs. Electric field due to the negative charge will be toward the negative charge. Now its directions is again along from AB. So this is the electric field due to the charge B, EB. Now its magnitude will be again same. This is R. We have to correct, थोड़ा सा correction करना जरूरी है यहाँ पे. This is R is between AB, but we need OA. So OA will be the value here. This is the square of OA. Square of OA. So square of OA, just OA the midpoint. OA is equal to OB is equal to R divided by 2. It means 10 centimeter. 10 centimeter means 0.1. 0.1. So this is the value of EA, and now EB. Electric field due to charge 3 microcoulomb will be 1 upon, same formula is here, that 1 upon 457 naught will be 9 into 10 raised to the power 9, and the QB the charge is 3 microcoulomb. 3 micro means 10 raised to the power minus 6 divided by distance. Distance will be OB. OB का square is 10 centimeter. 10 centimeter converts in meter. 0.1. 10 divided by 100. 0.1 का whole square. So now it is the uh, Newton per coulomb. It's the unit, and its direction will be along OB. Along OB. Along OB. So along OB, both E and EB both are in the same directions. So in vector formats, resultant field at the point of O is equal to vector EA plus EB. Since they are in the same direction, angle between them is 0. So if you apply the vector formula, is again will be the magnitude will be just adding of these one. EA plus EB both have the same magnitude, so we write this 2 times of EA. Now taken one value of this one. So now the value becomes electric field at the point of O is 9. 2 times of this is 2 times of taken any magnitude, either taken A or AB. Now this is the value 9 into 10 raised to the power 9 into 3 times of 10 raised to the power minus 6 divided by 0.1. 0 point means power is 2, 10 raised to the power minus 2. So if you simplify this one's 54 27. This is a 54. 3 into 9 into 2 is 54. 54, this minus 2 goes in numerator. So 9 plus 2, 9 plus 2, 9 plus 2 minus 6. So it is the value and unit in Newton per coulomb, and direction will be along AB. Now along AB, finally the value becomes 54, 54 10 raised to a 9, 11, 11 minus 6, 5 Newton per coulomb, and direction will be along AB. Question number 1.8, a part already we have discussed. Net electric fields at the point of it, at the point of net electric field at the point of O is a vector sum of this is 3 microcoulombs along this ones. We already discussed this. EA and this is minus, it's again same directions. So both are in the same direction. Therefore, EA vector EA plus vector EB, they both are in the same direction in magnitude. Now in magnitude, the resultant electric field at the point of O will be 2 times of EA, 2 times of EA, and putting the value of electric field, the formula of the electric field is 1 upon 457 naught. Taken the charges because both are the 3 microcoulomb and 3 microcoulombs. Both are equal in magnitudes. This is 3 micro mean 10 to the power minus 6, and distance we are taking the EA OB का whole square, OB whole square here. AB is 10 centimeter. AB is 20 centimeter. AB 20 centimeter. Obviously, OA is equal to OB will be 10 centimeter. You convert this in meter, 0.1 meter divided by 100. So here R square 0.1 whole square. So if you calculate this one, this value comes out to 1 upon 4 pi 9 into 10 raised to the power 9 and 3 into 10 raised to the power minus 6 divided by 0.1 can be written 0.2. Now this value becomes 3 into 2, 9 into 3 is 27, 27 multiplied to 54 into 10 raised to the power 9 minus 6, and this is plus 2, and the value becomes 54 10 raised to the power 11 5 unit Newton per coulomb. Its direction is along AB. So this is our first part. This is the first part. Now in second part, it says that second part it is given that if a negative charge of magnitude 1.5 into 10 raised to a minus 9 coulomb is placed at this point, what is the force experienced by this test charge? Now if I place a test charge at the point of this one, which is 1.5 negative 10 to the power minus 9 coulomb, this is the midpoint, and this is a negative charge. This is the negative charge. Negative charge is placed at this one. So we need the force on this one. Using this formula, F is equal to charge multiplied this one, F बराबर QE. F बराबर QE. Since net electric field we have at the point of is along this direction, along AB direction, even along AB direction. If you place the value, but our charge is negative. Therefore, if the charge is negative, the forces will be not along AB. The forces will be along AB, the direction of the electric fields, and the force will be along just opposite of the direction of electric field. It will be along BA. Now the magnitude will be here. F is equal to Q. Charge is 1.5. Only we need taken only the magnitude, not the sign of this charge. 1.5 is the charge, multiplied 10 raised to minus 9, and our electric field is already calculated at the origin, which is 54. 54 multiplied 10 raised to the power 5. So this is the Newton. If you simplify this one, simplified 54 15 1.5 into this one 6 on the 75 and 75 and it comes 81. This one 81 into 10 raised to the power minus 9, minus 9 plus 5, it will becomes 81. 10 raised to the power minus 4, minus 4 is the Newton, and its direction will be along OA. Now its direction along OA. Now our next question, question number 1.7 छूट गया था. We do here question number 1.7. 1.7. In question number 1.7, about the electric field lines. Electric field lines are continuous. Lines. They can be in line or the curve in any format. So there is no sudden break in the lines. So let us suppose if I take a charges here. Suppose this is a Q charge. This is the point charge. Let us suppose this is a point charge. This is positive charge. Electric field lines will be away from this one, starting from this point, away from this one. They will be they are continuous lines. They are not will be breaking. So infinite many lines will originate from the point of O, and they will end in infinite. They will end infinite. There is no breaking point. There is no breaking point. The lines will be continuous. Since these lines are not real line, these are the imaginary lines. We have to express the field, the direction of the field, so we using these. So since ये पॉजिटिव चार्ज है, ये हमारा पॉजिटिव चार्ज है, इलेक्ट्रिक फील्ड लाइंस यहाँ से स्टार्ट होगा, ओरिजिन इनफाइनाइट में जाके खत्म होता है. Now since electric fields, we know that the electric fields have the strength, the formula from the Coulombic law is 1 upon r square. जैसे जैसे we goes away from this point charge, our electric field की strength will also decrease. So now the decreasing of the electric field from this point to the infinite is gradually now a continuous process, not a sudden increase or sudden jump or a sudden gap. So electric field since हमारे पास एक ही रेट से we will decrease, एक ही रेट से decrease from this point to the infinite. So that's why field lines can be also continuous from origin to the infinite. They will be continuous. If there are somewhere breaking, if there are breaking means somewhere breaking, the continuous lines are breaking, it means that here the where जहाँ पे इलेक्ट्रिक फील्ड लाइंस नहीं होगा वहाँ पे इलेक्ट्रिक फील्ड हमारा क्या होगा, जीरो होगा. बट इट इज नॉट पॉसिबल. तो दैट्स वाई अगर यहाँ पे एज आई सेड दैट इन स्पेस पॉइंट चार्ज के चारों ओर वी हैव एवरीवेयर क्या होगा, इलेक्ट्रिक फील्ड्स होगा. दिस इलेक्ट्रिक फील्ड्स जैसे जैसे हम अवे फ्रॉम द पॉइंट चार्ज जाएंगे विल डिक्रीज. सो एवरीवेयर विल बी द इलेक्ट्रिक फील्ड्स. तो इफ द फील्ड लाइंस आर सडनली ब्रेकिंग, तो यहाँ पे फील्ड लाइंस मेरे पास नहीं है, इट मीन्स दैट यहाँ पे क्या हो जाएगा, इलेक्ट्रिक फील्ड लाइंस विल बी जीरो. So but it not possible, everywhere electric fields है. So therefore there would not be a sudden breaking of the electric field line. That's why we say that electric field lines should be continuous line. तो क्या होना चाहिए, बिल्कुल continuous होना चाहिए. electric field यहाँ पे होगा, it has some values at this point. And the second part, explain why two field lines never cross each other. This is our first part. Electric field lines are continuous. And the second part, in second part, any field lines, will not be field electric field lines will not inter any two lines will not intersect. Suppose that these are the field lines. One is this one, another field line is this one. So this is the point where they are intersecting. So we know that in the electric field, suppose if this is the electric field, we have in some charges का electric fields हम आते हैं, तो यहाँ पे ये field lines है. This is the P point. If you find the direction of the electric field at this point, we have to draw the tangent of this one, the direction of the electric field at this point P होगा. So since if I draw the field lines at this point, we will get there will be two tangent line. P point से दो टेंजेंट लाइन हमारी जाती हैं. दिस इज द वन टेंजेंट लाइंस एंड दिस इज अनदर टेंजेंट लाइन. दिस टेंजेंट लाइन, this will be another tangent line. These are the two tangent lines. Therefore here two electric fields, there will be two electric field lines. So at this point P we have two electric field lines. So it is not possible किसी भी पॉइंट में दो more than one electric field. So therefore तो EA, so obviously EA should be, ये क्या होना चाहिए, यहाँ पे एक ही फील्ड लाइंस होता है, एक ही फील्ड्स होता है, तो इन मैग्नीट्यूड डायरेक्शंस, तो ये इक्वल इन मैग्नीट्यूड शुड हैव द सेम डायरेक्शन. देयरफॉर तो इसका E2 का डायरेक्शन भी E1 होना चाहिए. इट मीन इट ओनली पॉसिबल दैट अगर ये एक फील्ड लाइंस हम इसको हटा दें, वी हैव टू रिमूव दिस फील्ड लाइन. तो दैट्स व्हाई इलेक्ट्रिक फील्ड लाइन विल नेवर इंटरसेक्ट. इलेक्ट्रिक field lines never intersect. This is a question number 1.7. Now question number 1.9. 1.9, this is x-axis, y-axis, z-axis. We have 2 points on the z-axis. In the negative direction of z-axis, we have a point A, coordinate 0, 0, minus 15 centimeter, and in the positive direction of z-axis, we have the coordinate 0, 0, 15 centimeter. This is positive direction of z-axis, and this will be negative direction of z-axis. So we have to find out the net charge which is placed along the z-axis, and what will be the dipole moment. So here the total charge will be is equal to which is 0, which is negative charge, this is positive, both are equal in magnitude, is equal to 0. And the dipole moment, so here the dipole moment is equal to charge into, this is the formula, charge into distance between these equal and opposite charge, which is AB. So we written dipole moment in vector format in P. So here the charges, taken any charges which is Q into AB, the distance between them. Here charge is 2.5 10 raised to the power minus 7 multiplied the distance between them, which is this is a 15 centimeter and this is 15 centimeter. Total will be 30 centimeter. 30 can converts into meter, 0.30. So now it is dipole moment magnitude, unit coulomb into meter, C into meter. Simplified this value 2.5 and 3, 73, 0.75, 75 in 10 raised to minus 7 coulomb into meter, written in the standard format. So decimal should be before decimal there will be one digit, that is 7.5, and here one digit we have dividing by 10, so it comes out minus 8 coulomb meter. Now it's a direction of the dipole moment is from negative charge to positive charge. Direction will be along BA. Along BA. Next question, question number 2.0. Question number 1.20. This is 20th question of chapter 1. Now in question number question number 10 of chapter 1, there is a this is our electric fields. Some strength is this ones, and there is dipole minus q and this is plus q. It's a strength dipole moment along this one is p, which is given this one. That dipole moment has the direction from negative charge to positive charge. It makes an angle 30 degree with the direction of the electric field. This is 30 degree. So we need torque. So what is the torque acting on this one? Torque is a vector quantity. Torque formula torque is in magnitude force into perpendicular distance between the two equal opposite forces. So this is the formula. General formula, we represent torque in vector format P cross E. P cross E the formula. So here in magnitude torque is equal to P cross product. P cross E means P sine the angle between the direction of dipole moment electric field is 30 degree. It means sine 30 degree. So if I place all values here, P has value 1 into dipole moment 4. This is 4. This is 4. 4 into 10 raised to the power minus 9 multiplied strength of electric field, which is 5 into 10 raised to the power 4, and sine 30 had the value 1 by 2. So if I simplify this one, it comes out 4 into 5 is 20. 20 into 4 into 5 divided by 2 and minus 9. Power is 8. Adding minus 9 plus 4. Now finally it comes out 10 into 10 ki power 10 ki power minus 5. Torque has here torque we will use the unit of the torque, not from here. From here very simple, Newton into meter. So Newton into meter is the unit. Now final value in standard format of this torque is equal to 1.010 raised to the power minus 5 and this 10. So minus 5 minus 4 Newton into meter.